Good morning. Hey, today we're going to be talking about wave interactions. I guess it could be afternoon by the time a couple of you get to hear this. Well, what are wave interactions? Well, one example of this would be reflection. Reflection is the bouncing back of ray of light, sound, or heat when rays hit a surface that it does not go through. Examples of this is light waves on a lake or in a lake. Um, they can create a mirror image of a landscape. Water waves are reflected when they hit the side of a boat. So these are all examples of reflection. We know what reflection is. Sound reflects off of, and that's what we call an echo. Um, Light reflects off of mirrors. These are all examples of reflection, whether it's a sound wave or a light wave or a water wave. Water waves reflect off the side of a boat. These are all examples of reflection. Okay, diffraction. Diffraction isn't something that we talk about on an everyday basis. Diffraction is when there's a change in the direction of a wave, when the wave finds an obstacle, edge, or opening. Okay, an example of diffraction, what I've tried to show here now is, let's imagine this is a slit, let's say between a door. And say, like in our classroom, I've got the two doors, and there's a little slit, little space between them. Diffraction, what you'll see is when the light goes through that slit. Some of you may think that the light is going to come out of here in a straight line, but that's not true. What it's actually going to do is it's going to come out and spread like this. That's diffraction, all right, because what's it doing? It's changing direction of a wave. When a wave finds an obstacle, an edge, or opening. So the light's coming through and it's bending, all right? It's coming through and it's going to bend around that turn. Water waves diffract around a block in a tank of water. Sound waves passing through a door diffract. If someone was standing over here, and there's their ear, and someone was talking right here, so let's put a set of mouth. Here's a mouth. There's some teeth. All right, and they're talking. Well, how does this person hear them? Well, the sound waves come through the door, and they go around the corner. All right, they diffract. Refraction. Refraction is the bending of wavefront as the wavefront passes between two substances in which the speed of the wave differs. All waves are refracted when they pass from one medium to another at an angle. So what I've done here is I've got an example. I've got this lawnmower. And with this lawnmower, I say I'm walking on cement and I'm getting ready to go into grass. Well, what's going to happen, and some of you guys have seen this, have experienced this, is when this front tire here hits the grass, what it causes this object to do is to change direction. Right? And what happens then is the lawnmower would start going off in this direction because the lawnmower can't go as fast in the grass as it can in the cement. And when that happens, it's going to change direction. In this case, it's going to turn to the left. Why? Because again, the lawnmower moves faster in cement than it does in grass. And waves do that same thing. This is called refraction. When you have, let's say, air and glass, you have something that's going from glass to air, it's going to refract. It's going to change direction because the sound or the light or whatever the object is, the wave is, can't travel as fast in air as it does in glass. Okay, the next thing I want to talk about here is interference. We have constructive interference and destructive interference. Constructive interference is when we have two or more waves that produce an intensity equal to the sum of the intensities of the individual waves. Destructive interference is when two or more waves that produce an intensity equal to the difference of the intensities of the individual waves. Okay, that's a whole lot of stuff. Let's talk about what it means. At the top, we have an example of constructive interference. What I like to say is that, let's say this first one has an amplitude of 5. This one has an amplitude of 7. Well, when we put these two together, we have constructive interference. We get 5 and 2 for a total of 7 now. We had constructive interference. They're going to be added together. The other thing we need to know about constructive interference is after the overlap, the waves continue to go on their merry way. They only overlap for a very small amount of time. Destructive interference. Right. Destructive interference. Let's say this one was a 4 and this one here was a -4. When they overlap each other, we get a resultant here of zero, no amplitude. This is destructive interference because they're going to cancel each other out to some extent. In this case, they're completely canceling out, but they wouldn't have to. You could have 4 on top and -3 on bottom, and then they wouldn't totally cancel. They would just be a little bit, they would have less amplitude when they overlapped each other. Okay, an example, standing waves. An example of standing waves is a pattern of vibration that simulates a wave that is standing still. Um, it looks like when you're jumping rope, all right, you have a standing wave. You have an amplitude on top and amplitude on bottom. That's an example of a standing wave. Standing waves continued. With a standing wave, let's draw an example of one. And there's my resting position, and here's the wave. Okay, in this we have what's called a node. A node is where there's no vibration. This right here is a node. There's no vibration there. It's at the that point part of the wave never moves up or down. But we have antinodes. This is where we have maximum vibration, and that would be at crest and at troughs. Those are our, what we call antinodes. All right, we've got a few questions here for you. How do waves behave when they hit a boundary, when they pass around an edge or an opening, and when they pass from one medium to another? The other thing is, what happens when two waves are in the same location? Just give you a little hint. This is right here. This one here is on interference. For those of you who are just listening to music, you have no idea what I just did that for. And then the last one here, how are standing waves formed? All right. Well, hey, I hope you enjoyed this. I'll catch you on the flip side.